All right, everybody, welcome back. This is the latter half of our number-based conversion notes. This is how to go from number that's already in our system, the base 10, the decimal system, and convert it into another system. In the last video, we ended with the number 37 with the binary. That was our first example. So what I'm going to do to start with in this one is take 37 and go back to the binary. So we have to convert from our system, in other words, base 10, decimal system, into another number base. So 37 in base 10 is equal to what in base 2? That's the question we are going to figure out. Here's what we do. First step, take the number and divide by the base you're going into. So 2, I'm going to say what is 37 divided by 2. Now, this is going to be a little bit tricky to do in Microsoft Word. So I'm just going to take a quick little side trip, and I'm going to go into the whiteboard, into Microsoft Paint, and show you what this looks like. Here's our last example. We'll take all that, highlight it, get rid of it all. Let's start from scratch. So 37 divided by 2. You need to be able to do long division. You need to be able to do long division. Welcome to high school, boys and girls. You do not want the decimal. Don't use your calculator. You must do this by hand. 37 divided by 2. You say, how many times does 2 go into 3? It goes in once. 1 times 2, 2. Subtract 3 minus 2 is 1. Bring down the 7, you get 17. Well, how many times does 2 go into 17? 8. 8 times 2, that's an 8, is 16. Subtract, you get 1. You get 18 remainder of 1. So let me go back to my notes. We get 18 remainder 1. All this year, it's now the end of December, near the end of December, we have looked at division with whole numbers, like we did back in the day in elementary school. Mod gives you remainder. Now, we're not doing this on the computer, but I'm just pointing out once again, remainder is something that comes up in computers all the time. So we get 18 remainder of 1. So what we do is we take the quotients and do step 1 again. So we're doing it again. Hold all of the remainders while you do this. So again, I'm going to show you here in a moment. We'll do 18 divided by 2. Hold on to the remainders. We're going to keep dividing until we get the remainder when the quotient is 0. When you get down to 0, there's nothing left to divide. So we're going to keep dividing until we get 0. And we're going to hold on to all the remainders. Hold all the remainders, not all of. Okay. Thanks, Microsoft Word. Grammar correct. So let's do it again. 18 divided by 2. This one's a little bit easier. 9. 9 times 2 is 18. Get a remainder of 0. Let's do it again. 9. We're using the quotient every single time. So 18 comes down here. 9 comes here. You do 9 divided by 2. 4. 8. Remainder of 1. 4 times 2 is 8. Get a remainder of 1. Keep going. We're waiting until we get a quotient of 0. 4 divided by 2, 2. With a remainder of 0. 2 divided by 2, 1. Here's a 2. Remainder of 0. Here's where we're going to stop. 1 divided by 2 goes in 0 times. This is our final problem, but we still have to finish the problem. 0 times 2 is 1, or 0 times 2 is 0, with a remainder of 1. we're finished. Now remember, we're going into binary. Where's our answer? Well, in binary, the digits are zeros and ones. Did you see anywhere on this problem, this series of problems, where you have lots of ones and zeros? The remainders. The remainders are the key. When you divide by 2, there's only 2 possible remainders, 0 and 1. You can't get a remainder of 2 when you divide by 2, otherwise you just haven't divided by enough. So the answer lies in the remainder, but there's a trick to it. If you remember our first problem, 37, it came from 100, 101. If you look at our remainders, the answer is from the final remainder going backwards. In other words, start with this number and go back. 100, 101 is our answer. We rate them from the ending back to the beginning. Let me go back and finish the notes here. So we have 37 divided by 2, get 8 remainder of 1. Again, let me just finish the problem here. So 37 divided by 2, I'm just going to abbreviate this, 18 remainder of 1. Then 18 divided by 2, I get 9 remainder of 0. 9 divided by 2 is 4 remainder of 1. 4 divided by 2, make the spacing consistent here. 4 divided by 2 is 2 remainder of 0. 2 divided by 2 is 1 remainder of 0. 1 divided by 2 is 0, which is where we stop, but we still finish the problem, remainder of 1. Your answer is the list of remainders from bottom to top. Remember when we did the other conversion, you went on the bottom 0 and you worked your way up? Same kind of idea here applies. So your answer is 37 in base 10 is equal to 100, 101 in base 2, which is binary. So it's repeated division using long division, figuring out the quotients and the remainders. That is how you convert from our system into another base. And as before, if I give you 10,000 of these problems, it's the same problem over and over again, just with different numbers. The only little exception, let's say there's like a 4A, 4B or something like that. Come on, Word, give me a good bullet point here. If you're in hexadecimal, convert any remainders over 9 to A through F, because remember, there is no such thing as like 11 in hexadecimal. It's really the letter B. We'll do an example of that here in a second. So here are the notes. Again, let me save those. They'll be in the folder on Schoology. Now let's go back to Paint. Let me show you some other examples. So I'll do another example of binary, just so you have it, and then we'll do another one for octal, another one for hexadecimal. So let's say we have the number 24 in base 10. We're going to make that equal to number in base 2. 24 divided by 2 gives me 1. Bring down the 4, you get 2. 24 divided by 2 is 12, with a remainder of 0. 12 divided by 2. This is so much easier on a whiteboard rather than a touchscreen laptop, but I'm doing the best I can. Hope you guys understand that. Yay, COVID. 6 times 12. 6 times 2 is 12. You get a remainder of 0. 6 divided by 2, 3. Remainder is 0. This is fun. 3 divided by 2, oh, here we go. Here's a remainder. So you get a remainder of 1. And then finally, 1 divided by 2 goes in 0 times. So there's where we stop, but we finish off the problem. You get a remainder of 1. So your answer is 1, 1, 0, 0, 0. Now, how could you check your work? Do the other process. Take that number, 1, 1, 0, 0, 0, and do what we did the other day in the other video. Multiply by 2, and then raise the powers from 0 to 4. That's how you check. It has to work both directions. let's do an octal. So when you get the higher numbers, this of course becomes a little bit more difficult because you're dividing by a bigger number than 2. But as I said in the other video, I'm not going to give you these gigantic numbers to do. That just wouldn't be fair if you're doing it by hand. So let's say, for this one, let's say I'm doing the number, let's say I'm doing 56 in base 10, and I'm going to convert that to base 8. So base 8, octal, 56 divided by 8. How many times does 8 go into 56? Well, I picked an easy one. You get 7. 7 times 8, 56. Get a remainder of 0. Wow. So bring down the 7, 8. That goes in 0 times. 0 times 8 is 0. You get 7. So the answer is 70. There's the 7. There's the 0. Easy peasy. Again, you want to check it? Cool, let's check it. Let's go the other way. 7, 0. Multiply by 8. Multiply by 8. 0, 1. 0 times anything is 0. 7 times 8, 56. You get 56. Has to work. You should be able to check every single one of your problems. As long as you know your basic division, basic times tables, you'll be good. Let's do one more. Let's do hexadecimal. So again, what makes this a little bit trickier is you're dividing by 16, which is a pretty big number when you're doing it by hand, but also then you have to worry about converting converting the remainders. So let me do let's think of a decent one. Let's do 192 in base 10. You're going to convert that into base 16. So the good news is there's not a lot of steps involved with these higher numbers. You're taking 192 divided by 16, but in doing so, you're already going to get down close to the ending number. So like binary, you're doing lots of little problems. For octal and hexadecimal, because you're using bigger numbers, you're going to do harder problems, but fewer of them. 16 goes into 19 once. 32. 2 times 16, 32. Remainder 0. Wow, that's kind of nice. Nice little remainder of 0. And then bring down the 12. There's your quotient. 16. 0. So there's where you stop. So again, you're doing basically just two problems. You have a remainder of 0 there. 0 times 16 is 0. So you have a remainder of 12. Now, your answer is not 120. That 12 is not a 12. It's not a 1, a 2. It is the corresponding hexadecimal digit. Again, A is 10. B is 11. C is 12. D is 13, E is 14, F is 15, and so 12 is C. So your answer is really C0. There you go. That's how you do it. Questions? That's why we're doing these before class Thursday and Friday, because on Thursday and Friday we'll do some practice and make sure you guys are okay with this. In the meantime, if you do have questions, let me know. Again, I could give you a bajillion of these problems, and it's the same every single time. It's just a matter of doing the right math. So, take care. Thanks for watching.